Hey guys, thanks for joining today's session. Yesterday, we had an insightful discussion about Docker, covering its fundamentals, advantages, architecture, and the key differences between Docker, image, and container. Let's have a quick recap. Okay, so what exactly is Docker? Can someone tell me? Can someone tell me? Yes, I could see two answers. Very good. Let's say you build an application, okay? It works perfectly on your laptop. But when you try to run the same application in your friend's laptop, it fails. It is not working. Why does this happen? Can someone tell me? Because of the missing dependencies. Because to run my application, I need to have some dependent files should be there in my system, and also the same thing should be available in my friend's laptop. Okay. So because of the differences, right? In my laptop, I have all the dependencies that are required to run my application that is available. Whereas in my friend's laptop, only the application is there, only part of the dependencies are there, not the entire dependencies are available. Because of which in his system, it is not running correctly. This is where, this is exactly where the Docker comes in. How? So Docker allows us to package everything our app needs, like all the dependencies, libraries, including your application code into a container. Container is something like a box. That's what I told you. One second, so this is what your container. Container is something like box. You just think that way, okay? So what we do here is, okay, what we do here is we will package everything. For example, this is my laptop. So this is my laptop, okay? This is my laptop. In my laptop, what I do, I just developed a retail app. This app is running perfectly in my laptop. So in order to run this app, it requires some the packages, all the let's say Python and other thing, right? Other Python related packages, everything is required to run this application. Everything is working fine. So now my app is working fine, the retail app. When I share this same app to my friend's laptop, what happens is there are some packages that are required in order to run my application successfully. I need to ship the application along with the dependencies. Your friend, right? Listen to my friend. After receiving the application, he has to install all the packages here. While installing the packages, also you might tend to develop some issues. What I do is, instead of shipping the application and the dependencies to my friend's laptop, what I do is I will push all the dependencies that are required to run my application successfully, along with my application into the container. This box, okay, I'll put it in a box. I'll just package it everything, and then I will send this container to my friend's laptop. What will happen is, in this case, he need not to install anything in his laptop, and all the required packages, libraries that are required to run my application successfully are already available inside the container. Hence, he need not to do any installation, anything. Okay. Hope you understood the advantage of Docker. Okay. So it works consistently across all the systems. Okay. So why do we need Docker? So the same thing, right? So we install dependencies manually, configure settings, and cross our fingers that it works on another machine. It sounds painful, right? Because you cannot expect the target environment or your friend's laptop or other server when you ship your application there. When you migrate your application there, it should work the way how you expected, right? So the other target environment, you need to install all the dependencies that are required to run your application. This is painful. So that's the reason why what we do is we package all the dependencies, everything in order to run my application successfully inside the container. If I ship the box or the container to other environment, it will run successfully and consistent it will run. So, okay, the reason why we like Docker, right? Portability. The one is portability. So, what is portability? It works on my machine. It works on my machine, but it is no longer a problem. Okay, it works everywhere. No, working the retail application in your laptop is not only sufficient, right? It has to work across all the systems, including all the mobile phones. That is very important. So that's where with the Docker we can achieve the portability and lightweight. The another salient feature of Docker is lightweight. Okay, what is lightweight? Why Docker is lightweight? Can anyone guess? That's because unlike our virtual machine, unlike our virtual machines, Docker does not need a separate OS. Okay, let's say you have 10 containers, container one, container two, let's say you create three containers. All the three containers share the your host operating system kernel. Each container does not require a operating system, separate operating system. That's the reason why the Docker is lightweight. We call that as a lightweight. Okay, and it's fast deployment. So no more long setup process. Just pull your Docker image. Once you create the build the Docker image, just pull it and start your application in seconds. Okay, fast deployment is pretty fast because you once you build the image and then for to build the container and then if you push it to a repository, right? In other systems, just pull that the image and then you create the container. It's pretty faster. And scalability. What is scalability? Let's say you suddenly get 10 times more users on your application. What would happen? What will happen? With the Docker, you can quickly spin up more containers to handle the load. Instead of having one container, Docker container, you can spin up one, two, three, four, five, six, seven containers. Right? By spinning up, in the sense creating more number of containers, can help you to handle the load. Even if the number of users increases, it can. That is what scalability. Next, we discussed about the Docker image and Docker container. Can someone tell me what is the difference between these two? Yes, very good, right? The container is a template. Very good. Any other answer? What about container? Yeah. So I just gave you this simple example. Docker image is something like your housing blueprint, house blueprint, and you cannot live on this paper. Blueprint is a paper, right? You cannot live on top of the blueprint. It's a paper. If you wanted to live, you need a house, right? So container is something like an house. This is a blueprint. This is an house. Okay, actual house. The container is an instance of your image. You just think that way. Okay. So Docker image is a template or a blueprint. Okay, and the Docker container is a real thing, right? It's an actual house. Okay, so now here is something interesting. If I change a running container, does it change the original image? We discussed about this. Image is a immutable one, whereas the container is mutable one. Like you can modify your constructed house, right? You can modify it. But blueprint, can you modify it? Blueprint is something like now it's a fixed one. You cannot modify it. It's immutable. Docker image is immutable. You cannot modify it. The container, you can modify it. The question to you all is, if I change a running container, does it change the original image? No, right? So no images are no, because images are immutable. Any changes happen only inside that specific container, right? A container, unless we commit the changes to your new image. Okay. So, right. So you need to commit in case you want to do that way, right? You need to commit the changes to your new image. Okay. So next one is we discussed about the Docker architecture. As part of this, we discussed about the Docker client and the Docker daemon, which is the Docker host and Docker daemon. And also we discussed about the Docker image and container and Docker registry, like Docker Hub or ECR, Elastic Container Repository, right? Okay, so now this is what we discussed. Okay, so okay, this is what we discussed in the previous session. Next, what we'll do is we'll just continue with the hands-on part.